Cognition, an introduction to cognitive science. Linguistic cognition. Benjamin Miss. Language development. Language is a massive topic and about as well understood as metaconsciousness. Philosophers and early psychologists have argued variously that language is required for thought, or that much of cognition requires language. Modern research suggests that neither of these things is completely true, though without language it is likely that something is indeed lacking from the human experience. The development of mind and the acquisition of language occur together. To some extent, all human languages are alike, though the reasons for these similarities are unclear. It appears that language is unique to itself, in that lacking language may not make it impossible to think, but rather impossible to communicate effectively. Language does not seem to influence cognition, but it is required. There is even debate about whether human language is special, unique to Homo sapiens, as there are those that argue that Homo erectus had what we would call language. This section will consider what the mind looks like without language, the development of language, and how language interacts with the mind. It is most likely that language did arise with early Homo sapiens, specifically with a genetic mutation that spread through the entire planet's population of humans within a short period of time. Some modern humans with errors in this gene have difficulty communicating. They have trouble with coordinating their vocal movements and with sentence structure. It makes sense that whatever it was that made us fully human, our capacity for language giving rise to song and poetry, hypotheticals, and stories of gods and monsters, coincides with the cave paintings that arose at nearly the same time in both Western Europe and Indonesia. A shift in the mind leading those early modern humans to create what we would call art. Whether effigy, superstition, or the existential desire to assert one's own existence, it is as good a marker as any for the beginning of the modern mind, dating to less than 50,000 years ago. Linking art with language in the evolution of the mind is useful, but by no means undisputed. In fact, the study of the evolution of language is marked by an incomplete record. The closest thing to a fossil record for language is writing, which dates back barely 5,000 years, and with debate about what counts as a complete writing system. Proto-writing, which consists of short strings of pictographic symbols, may stretch back 8,000 years. Consider the Jiahu symbols, discovered in Henan, China, dated to approximately 6000 BCE. While these are interesting, there is far too little information to support that this represents a fully developed system of writing. The first complete writing system came from Sumer in Mesopotamia approximately 5,000 years ago, which began as pictographic and eventually developed phonetic elements. It was called cuneiform, from the Latin word for wedge, due to the shapes made by poking a reed into clay. Shortly after, systems likely developed independently in Egypt and China. It was much later that writing developed independently in the Americas, as evidenced by the Mayan script. Written language likely did not come about until humans had a need to record information due to farming and trade. These two markers, the creation of permanent art and the development of written language, are separated by tens of thousands of years. This means that even after humans developed modern brains and modern language, humans still lived a hunter-gatherer lifestyle for a long time. So, what was it like for those Bronze Age humans as they developed a civilization so different from anything they had adapted to? That is discussed in detail in the chapter on evolutionary cognition. Once people began to write things down, information could be stored and shared more easily, and technological advances stopped requiring direct oral communication. Language continues to change, and the writing system is evidence of that. You can see the results of language change by looking at English spelling. Through, though, and tough all end with OUGH, but are pronounced differently. This and think Both start with th, yet they sound slightly different. Old English sounded very different from Middle English, which is nearly inscrutable to modern English speakers. In fact, Shakespeare may be difficult to read, yet it is actually early modern English. This dynamic nature of language, the ability to change, is one of the key features of human language that makes it different from any animal communication system. Language is communicative. It allows for the passing of information. Arbitrary. Words have little or no connection to the things they name. Structured. Syntax, similar to what we think of as grammar. Generative. You can express anything you can think of. And dynamic. Language changes. The two components that really make human language unique are the features of being structured and generative. Our structure is what allows us to talk about the past and future, or even abstract hypothetical situations. Think about how we add tense to verbs to give us the past and future, or why we can't just randomly change the order of words. Syntax is not quite the same thing as the grammar you learned in school, but rather the rules of language. If I end a sentence with a preposition, you understand what I'm saying. Prescriptive grammar is the rules for formal writing, which is not the same as the rules for language. The generative property of language means that you can create sentences no one has ever spoken before, of increasing length and complexity and meaning. The only limit is the amount of information you can hold in your mind. Animal communication. There have been many claims regarding primate language, and very few of them are true. Humans truly are unique on this planet in regards to language. Non-humans can communicate, but they do not have the ability to produce language as we know it. Most of the differences involve arguments about meaning. Of course chimpanzees can communicate, but do they have language like we do? They do not. First, consider bees. Bees dance. They shake their buzzing bodies to let their fellow bees know where the best food is. They can communicate direction, distance, and the richness of the food source. The bigger their waggle, the better the food. The angle of their dance communicates direction, and the duration of the waggle communicates distance. Would anyone argue that bees have language? They are limited to these pieces of information, and they cannot even communicate height. If a bee came across a rich food source 20 feet above the hive, that poor bee would have no way to communicate the location. Up is not part of their vocabulary. How about those big-brained dolphins? They can be trained to retrieve objects and even follow commands with complex syntax, like the difference between put the block on the stick and put the stick on the block. Dolphins can learn to whistle for objects, but their vocabulary is far smaller than ours, and they don't appear to communicate with each other the same way. While studying dolphins is difficult due to their different environment, their high-pitched whistling and the costs associated with keeping those large, intelligent mammals, they don't seem to be doing much more than a pet dog. Some dogs can follow complex commands and communicate a few different things with their barks, but you'd be hard-pressed to find someone to argue that there's a dog language. Gray parrots are highly intelligent, and they have the rare ability to mimic human speech. The famous gray parrot Alex was able to answer questions like, "How many green squares?" and select the correct answer from a tray of green and blue squares, circles, and triangles. An interesting trick, but not language. Mostly, Alex asked for treats, or to take a break from the tests. Which brings us to the great apes, those species that are most closely genetically similar to humans. The closest genetically and most widely studied are the chimpanzees, both the common variety and the bonobo, often called the pygmy chimpanzee. The most famous gorilla studied is Koko. According to Dr. Penny Patterson, Koko's trainer/handler/best friend, Koko knew over 1,000 signs and understood over 2,000 English words. Patterson called Koko's language GSL, for Gorilla Sign Language, denoting it as a unique thing. Some estimates place Koko's abilities along the lines of a 3-year-old human. That sounds impressive until we consider that 3-year-old humans don't actually have language the same way we do. Language doesn't fully develop until between the ages of 4 and 5. This is when a child actually has the full syntactic structure of language. Coco's story, however, was sensationalized. She appeared in media, including the popular show 60 Minutes, where they showed a conversation with her. Many statements made by the people who cared for Coco overplayed her abilities. They frequently described the conversations they had with Coco. Coco can answer questions and ask for things, but she is not capable of conversation in the traditional sense. It is often difficult to understand Coco, and most videos of Coco are heavily edited and overlaid with explanatory commentary that doesn't seem to match the actual gorilla behavior. It is likely that Coco's language ability has been overstated too, and her communication abilities are more in line with a 2-year-old, which is what is observed in other primates. 2-year-old humans are not easy to understand. The most promising communicators are the bonobo chimpanzees, and it has been shown they can learn symbols and signs, but that, like Coco, they tend to max out their abilities, comparable to 2-year-old human children, and they learn slowly, without the rapid growth of vocabulary and syntactic ability seen in human children. One of the most talented, Kanzi, has been described by Dr. Sue Savage-Rumbaugh as showing abilities beyond what is typical for bonobos. It is important to remember that the apes studied are not typical of their species, and even then they fall far short in their abilities to acquire human language. In the image here, Kanzi is using lexicograms, a system designed to maximize the ability of the apes to communicate. Teaching human language to non-human species might seem possible, but they all lack the complexity of communication and the putative instinct that humans seem to have in regard to language. Animals that learn some human words or even strings of words don't ask questions or discuss hypotheticals. To them, learning our language is a tool to get them food or other things they want. It is not a drive or a way to access their minds. Those two components, the productive ability to say new and creative things, and the structure ability to naturally put words together in ways allowing for complex meaning, appear to be missing. Perhaps the uniqueness of human language is an emergent property, a product of other developments. This would make human language quantitatively different from non-human communication, a matter of degree where we have greater cognitive abilities, so we do more than animals, but in a similar way. More likely, human language is the result of a mutation, linking the ability to produce words with meaning with the ability to produce structure, leading to the massive productivity of language, a qualitative difference. Considering non-human species, from cephalopods to monkeys to highly social fish and birds, communication appears limited to a small number of signs. This can be calls, movement, or in the case of cuttlefish, color changes. Nearly all species communicate. However, communication is limited and requires context. Those species with larger social groups and higher intelligence appear to use more calls, but in their natural environment, the amount of symbols used numbered no more than a few dozen, while for humans our vocabularies stretch into the tens of thousands with no upper limit and an incredible ability for abstraction. Ask a fish about the concept of justice. Next, we consider two illustrative situations that help us understand this human drive for language and how it is an integral part of our developmental cognition. First, consider the wild child, Jeannie Wiley, and then the fairly recent natural development of a new language as observed by the linguist Julie Shepard-Cagle. Jeannie and the critical period for language acquisition. First, it is important to consider the place of Jeannie in history. The discovery of the young girl was practically an answered prayer for those debating the influence of nature and nurture on language. The study of language had recently undergone a revolution in the late 1950s and 1960s. Noam Chomsky, a linguist at MIT, wrote a scathing review of B.F. Skinner's book, Verbal Behavior. Skinner was the leading behaviorist of his day, framing the world in terms of reinforcement and punishment. Operant conditioning consists of the following components. Positive reinforcement, giving you something you want to increase a behavior. Negative reinforcement, taking something you don't want away to increase a behavior. Positive punishment, giving you something you don't want to decrease a behavior. And negative punishment, taking away something you want to decrease behavior. There's a great deal of misunderstanding, likely because of the triple negatives. In negative reinforcement, we have the word negative, the phrase taking away, and the word don't, which leads to an increase. People often confuse negative reinforcement and positive punishment because they think that negative means bad and positive means good. That the phrase positive punishment is an oxymoron. Actually, positive means you're adding something, and negative means you're taking something away. Think of it like this. You want your child to practice the violin more. When they practice, you can use positive reinforcement by giving them a candy or a toy that they want when they finish. You can use negative reinforcement by telling them they don't have to do a chore they dislike, such as vacuuming or doing the dishes. You can be an abusive asshole and hit them for not practicing, using positive punishment. You can use negative punishment by taking away their favorite toy or their cell phone. Behaviorists ignored the mind. They didn't believe our decisions really mattered. Behavior could be predicted with great accuracy simply by studying the organism's behavior and environment. Skinner attempted to describe language acquisition as a system of reinforcements for using language correctly and punishments for using language incorrectly. Chomsky argued that human language contained components that could not be learned. He showed that children only receive what is called positive evidence, which is how adults use language. Yet children make predictable errors, and other errors they could make are never made. For instance, in the sentence, "You have a green ball and I want one too," what does the word one refer to? Adults and 18-month-old children alike understand that one refers to green ball. Consider how unlikely it is that an 18-month-old should develop this level of understanding. In order to understand that one means green ball and not just ball, the child must observe something, then ask for a noun with an adjective descriptor, and then observe someone offer the object with a different descriptor, such as a red ball instead of a green ball. Then have the person who asked has to say something like, "No, I want one of those," pointing to the green ball, solidifying that one refers to all the properties of the object. If that doesn't sound obvious, consider that one can be used like this. "You have a red ball and I have a green one," where one refers to the object without the adjective. Since children and adults develop the understanding of meanings like this, they shouldn't be able to learn from the evidence alone. Humans have some innate language abilities. Chomsky, a linguist, was so persuasive that he changed not only the study of language, but the study of psychology. Note, I would suggest it is possible a child can learn through analogy, learning two different uses for one. Yet I would still agree with Chomsky's general point. Behaviorism did a lot of good. Heavily influential, the behaviorists argued for the value of education and rehabilitation. If everything is learned, then individual failures are the failures of our society. Behaviorism isn't wrong, but Skinner's overreach led to the loss of favor and the focus on the study of the mind, the birth of cognitive science. Chomsky and his followers pushed the study of linguistics and language into the cognitive realm and shifted psychology back to the study of the mind. It didn't hurt that computers were becoming powerful enough to analyze complicated EEG data, and that the ongoing development of CAT and PET scans allowed researchers to look at the brains of living people. This revolution of the mind was waiting for Jeannie in order to help us understand language acquisition. What happened to Jeannie was sometimes called the forbidden experiment, isolating a child from language to see what would happen. More horrible than it could possibly be informative, no one would ever condone such a thing. And yet for her whole life, Jeannie had been kept isolated, locked in a dim room with little sunlight. Under control of her abusive, mentally ill father, she spent her days either trapped in a cage-like crib or tied to a potty chair. She was rarely spoken to, and it is believed she was beaten if she made any sounds. Her mother was legally blind and unable to stand up to Jeannie's father. Shortly after her 13th birthday, her mother stumbled into a government-affiliated building, and social workers and police got involved. Jeannie's story is tragic. It begins tragically and ends tragically. There is no excuse for harming a child, and those that were supposed to care for and protect her failed woefully. For a while, a brief interlude in her isolated life, Jeannie was the center of the academic debate on the critical period for language acquisition. She lived with researchers who became her foster parents. She had tutors and was visited by scholars. At first, Jeannie progressed rapidly, learning to navigate her environment and care for herself. She learned words so fast as a young child. She was inquisitive and appeared to show that there was no critical period, and that not only was language acquirable at any age, but that her early maltreatment could be overcome. Until the progress slowed. It was clear that Jeannie could recover to a point. Her EEG showed abnormalities, and there was debate about the level of her cognitive abilities. The money ran out. Her foster parents sent her back into the system, and Jeannie has languished in an adult care facility somewhere in Southern California ever since. The rare anonymous report shows that her language abilities regressed, without intensive tutoring and assistance. The debate around the critical period for language acquisition has never been completely settled, but evidence strongly supports the idea. NSL and the syntax instinct. We consider the failure of apes to learn language, the tragic story of Jeannie, and the incredible human ability of language when nurtured and encouraged, with no fossil record. For language, we can only ask, where did language come from? Did it develop slowly over generations? Did it evolve with natural selection changing human brains, bringing Homo sapiens through different levels of language ability? Or did language happen quickly, developing over a few generations, as genetic change made humans capable of this ability? There have been hints of such an instinct for language throughout history. When two language groups would need to work together, they would develop a pidgin language. This pidgin was usually a mix of words from both languages and required context for communication. There would be no syntax or structure, only words for items and other things necessary for trade. However, when those groups worked together for long enough, a new language called a Creole might develop. The Creole language would be just like any other language, with sound and structure and the ability to express any thought or question imaginable. It is believed that the new language was created by the children of those different groups who were learning language and added syntax to the pidgin automatically. Nicaraguan Sign Language, or NSL, is one of the world's newest languages. Note that the official name is Idioma de Señas de Nicaragua, known as ISN, though it is still often referred to as NSL. Well, most languages in the world are disappearing, with half of the world's languages having fewer than 10,000 speakers. NSL appeared in the 1980s in the Managua region in Nicaragua. Up until then, deaf people were scattered throughout the country, with no standard school or ability to communicate. Julie Shepard Cagle, having recently completed her PhD at MIT, was asked to visit and try to understand what the children were saying to each other. The teachers at the school were attempting to teach written Spanish, not a sign language. They believed the children were using a simple pidgin gesture system. Cagle, who should be a household name instead of so many useless celebrities, quickly realized that the children were communicating in a fully formed language. She avoided introducing any other signs to the children, and instead endeavored to learn and record their language, basically giving humanity a window into the birth of language. Though contact started in the 1970s, when Cagle arrived, she was able to observe that the younger children had added syntax and were communicating differently than the older children. While the older children were using what can be described as a pidgin-type language, the younger children had a full language containing syntactic structures such as verb agreement. In English compared I am to you are, and you walk to he walks. The younger children had taken the pigeon of the older children and added structure automatically. This supports Chomsky's notion of the poverty of the stimulus and the unlearnability of language. We do not need to be taught everything about our language because our brains are so suited to acquiring language, we will create it if it doesn't already exist. This brings to mind Voltaire's notion that if God did not exist, it would be necessary to invent him. Some ideas are so salient, so well suited to the very structure of the human mind, that the mind will create the same concept over and over, no matter the environment. It was precisely this type of reasoning that could lead Carl Jung, an early student of Freud's, to suggest that we all share a collective unconscious. While Jung's outdated notion that the unconscious mind of all humans was populated by the same types of figures and ideas, we cannot ignore the fact that the structure of the mind plus aspects of the shared human environment would lead to minds that function more similarly than different. Evidence, like the human drive for language seen in NSL, supports the notion that language is a fundamental property of being human. That mutation allowed for the merging of sound and structure, giving us that drive for syntax. This mutation was so beneficial, it spread to the entire population of the species in a small number of generations. This mutation was so beneficial for survival and reproduction that now every member of the species acquired that mutated gene. Evidence from Nicaraguan Sign Language supports the notion that language developed immediately in one generation of children that had that gene. Early human species could learn words in the same way apes can learn words. Add this new ability for structure and productivity, and humans became humans, maybe even as quickly as NSL changed from a few gestures in the playground to a language capable of expressing our most beautiful poetry. Child language acquisition. Erich Lenenberg was one of the first to argue that language is biological and can be explained by the structure of the human brain and vocal tract. He studied children of various language origins and found they all followed approximately the same pattern of acquisition. Simply, they progress from the cooing stage, where they begin to utter a wide range of sounds that aren't necessarily language sounds, to the babbling stage, where they begin to utter a smaller set of phonemic sounds similar to those produced by the adult speakers around them. Then they enter the one-word stage, which is what it sounds like. One word can be used to describe similar things, like the moon and a ball and a cookie and a circle. The two-word stage is the production of two-word sentences, usually the two most meaningful words, to convey meaning such as daddy up, meaning I want daddy to pick me up. Up until around 2.5, their vocabulary is rather limited, but at that time they enter a period of rapid learning, where they learn, on average, a new word every couple of hours. By the time they are 5, most children have learned the full grammar of their native language. This is true no matter what the language is, whether English, Chinese, Cree, or Xhosa. Language and thought. The concept of linguistic relativity is generally associated with Benjamin Whorf, and is often referred to as the Whorf-Sapir hypothesis. Edward Sapir studied as an anthropologist, and Whorf was an engineer whose studies of language as a hobby were so influential that he was invited and asked to teach graduate courses at Yale without having a graduate degree himself. They were both experts in Native American languages and were interested in how language influences thought. Critics have pointed out areas where Whorf was wrong, and for decades the idea of linguistic relativity was questioned. Some have even used the concept of linguistic relativity to justify the oppression of people who think differently. Yet it is logical that people experience the world differently based on their environment. Scoring high on the SAT might help you get into a good college, but it won't necessarily help you track prey, or build a shelter, or know which plants are edible. The strong version of the linguistic relativity hypothesis this is an example of the word hypothesis being used incorrectly to describe a theory, is that language controls thought and perception. If it is impossible to express something in a language, it is impossible to think it. George Orwell, in his seminal novel 1984, would be a proponent of this idea. In 1984, the government developed a language called Newspeak that did away with words and concepts relating to freedom and revolution, so the population could not conceive of those ideas and therefore never revolt. I don't think anyone really believes this. If you've ever observed an infant problem solved, you've seen that thought can exist without language. The weak version of the linguistic relativity hypothesis is that language influences thought. This version is widely supported by evidence and is a fertile area of modern study in the language and thought. One of the most influential researchers in this area is Lera Boroditsky, the cognitive scientist at UC San Diego. She demonstrates time and again that the language we speak influences the way we view and interact with the world. One example is the Cook Theor, an Aboriginal community in Australia. These people have an incredible sense of direction. At any moment, they know which cardinal direction they are facing. They do not use words like left and right, but instead use words like east and west. When asked to put pictures in order to tell a story, English speakers will put them in order from left to right. That is how we view the world, how we view time. The Cook Theor will, no matter which direction they are facing, put the pictures in order from east to west. That is how they view the progression of time. And Hebrew speakers will arrange the pictures from right to left, influenced by their written system. Language can influence how we arrange the world, and these differences can be measured in experiments that measure reaction time. Speakers of Russian have a different word for light blue and dark blue. Both Russian and English speakers were shown two blue squares, sometimes the same blue and sometimes a different blue. They were asked to mark whether these were the same or different. Russian speakers were faster in categorizing shades of blue as different due to their different names for them compared to English speakers. Using human language is the most complex task we humans engage in, yet we take it for granted because it comes so easily to us. We speak without thinking. We don't remember the time before we understood language, so we cannot appreciate the fact that nearly all of human culture, civilization, and knowledge is built on this special ability. Thank you.